Hi, my name is Ellen, and this is the final project for managing machine learning projects. I'm focusing on a problem that appeared in my community. School enrollment predictions can have huge impacts on communities. My local school district recently announced that they had to close one of three elementary schools, and this is just 10 years after they built the most expensive elementary school in the state of Washington at a cost of more than $50 million, because at that point they were expecting school enrollments to continue to rise. School closures not only create disruptions in the community, they also make taxpayers skeptical when they're being asked to increase their property taxes. I think there's got to be a better way, and as a result, I am proposing the Washington School Enrollment Prediction Project. This will give school districts across the state of Washington uh, accurate school prediction or school enrollment predictions using a robust machine learning model. This will use publicly available data that covers economic, demographic, and housing data to generate accurate predictions for every school district in the state. These predictions would be updated monthly so that you can track changes over time, and that will allow school districts to dynamically adjust their plans as circumstances change. This helps avoid the costly errors that erode community confidence and give school districts a better shot at passing the levies when they need to upgrade or build new schools. We're going to use the CRISP DM model to go deeper into the foundations of this project. And you'll notice over the next few slides that each section is color coded. So we're going to start with the business understanding. So the target user for this project would be administrators and school board members who are representing school districts in Washington State. These school district leaders rely on enrollment predictions for planning everything, but it's particularly essential when they are asking their communities to pass funding levies for capital projects. This requires longer term enrollment predictions, and as property taxes or as construction costs have risen, so have local property tax rates. And that makes some communities too expensive to attract young families, leading to reductions in enrollment. Today, districts use private consulting firms to provide one off enrollment predictions, and that means they only actually get this data when they are preparing to ask for a funding levy. These reports are expensive, they're limited in their scope, and they're not updated ever because of cost, and they are notoriously inaccurate. The expected impact of a publicly funded statewide machine learning model for providing school enrollment predictions would be that the predictions are more accurate and they can be adjusted over time to optimize, or the model can be adjusted over time to optimize for accuracy. Also, because it's a shared resource, it would allow and enable forward looking planning between districts. Some of the outcome metrics is that we would want to look at would be that the model is updated monthly so that shifts in demographic, economic, and housing changes would be reflected in the enrollment predictions, and that our actual lookbacks deviate less than 5% from the predicted enrollments for some percentage of the districts in the state. The output metrics would be the mean squared error, and the goal there is that that error rate declines over time. We've got some constraints that make this compared to some of the machine learning projects out there, relatively simple. The current model is so ad hoc and occasional that scheduled monthly updates would actually be an enormous improvement. And batch processed updates would be, again, a big improvement over the way things are done now. Uh, One additional constraint that is worth noting here is that because this will be used by the public, as well as school district staff and administrators, that means that the model needs to be as interpretable as possible, and really simplicity and transparency are key for driving that. The relevant features here would come from data from three major sources: demographic data, economic data, and housing data. And all of these sources would be aggregated both by time and geographic location, and they would be able to be broken into each school district for the various time periods that we'd be looking at. Uh, the solution, just to recap, is a statewide machine learning model for predicting public school enrollments that gives school districts and their communities a good way to anticipate when investments in school infrastructure are needed and support that with data that will help communities have confidence that their taxpayer dollars are going to be spent wisely. Our validation plan is that after we complete preparation of the data, we would build a heuristics-based model, as simple a one as possible, to validate the overall approach and to identify the key data features. This would also allow the team to build prototypes that could be tested with administrators, community members, and experts in the various fields to make sure that we are representing the data accurately. We would then begin building and iterating on a machine language model, and we would do multiple regressions to weight features and to eliminate any feature that is underperforming. The team would then identify and add new features and new data sources to continue to stress test the model and make sure that we are achieving the optimal balance between robust predictions and as few features as we can get away with. Interpretability and performance will be evaluated throughout the process, and progressively throughout the process, we will also add other monitoring systems so that when we are done, we have a really robust, easily maintained solution. Once we've met our predefined output metrics and qualitative user feedback indicates that we have a working solution, we'll run our final test with set-aside test data, evaluate the results, and if everything looks good, we'll deploy it. Our next steps would then be continuing to monitor the results and identifying any next generation models that would be needed post-launch. So we'll talk about challenger models in a moment. There's some key design decisions that I want to walk you through. So cloud versus edge machine learning. Because this is used by district staff and administrators during working hours, you can assume that internet connectivity is there. The data sources are already aggregated and publicly available, so privacy issues are minimized, which makes this a really good candidate for cloud-based machine learning. Also, these data sets tend to be pretty large, even if you're only looking at one state out of 50. So that can be a way to reduce the processing time. Offline versus online model retraining. Again, this is a good candidate for offline model retraining because it will be scheduled monthly. And similarly, the batch versus real-time prediction generation, we don't need ongoing regeneration of model predictions. Once we've updated the model and retrained it with new data sources, we can generate new predictions and restart that cycle. All of that is an improvement over current processes, and I think would be a great starting place. There's some risks with this process. Because it's a public project, making sure that bias specific to any demographic group is minimized is essential. And we would do that using frameworks such as LIME and SHAP. Data drift is also critical if the training data is not representative of the actual trends in Washington State. The model's predictive abilities will decrease. So making sure that we have sufficient monitoring in place is key, and making sure that we are, keeping those accuracy metrics front and center is essential. Concept drift is a little trickier when there are major cultural shifts. The recent experience with COVID is one, but I expect we may be seeing more of that. It may cause the same features to take on new meanings. And in that case, challenger models that are based on sort of anticipated foundational or cultural shifts to feature interpretation could be a way to address that. Data pipeline issues may be a risk as well. Publicly available data sets have been historically pretty predictable, but changes to data structures could have difficult to diagnose impacts, and some data sources may no longer be published going forward. So, making sure that we are manually reviewing essential data sources combined with monitoring are good ways to mitigate that risk. And finally, because it is expected that there will be multiple contributors to this project. Automated and very rigorous versioning is essential so that the model can always be reverted to a previous state if needed. In closing, I want to just recap the benefit of this project. Better enrollment predictions can help schools plan more efficiently. That means that when taxpayers are asked to fund school related projects, they can have higher confidence that the money that they're spending will result in valuable community investments. That means that our state public schools will serve our kids better, and that Washington State will remain a leader in technology and will remain a high growth state. Thank you for taking the time to review this, and I hope it was useful.